Test types. A test type is focused on a particular test objective. Test types fall into the following categories: functional testing, non-functional testing, structural testing, and testing after code has been changed. So regarding functional testing, we have process flows, state transition models, security threat models, plain language specifications. Regarding non-functional testing, we have performance models and usability models. Regarding structural testing, we have control flow model and the menu structure model. Let's take a closer look for each of the types. Functional testing is testing based on an analysis of the specification of the functionality of a component or system. It's also called specification-based testing against the specification. It's concerned with testing what the system does and not the way in which it does so. Considers the external behavior as the input to and output from the software. Functionality can be described in work products, such as requirement specifications, use cases, functional specifications, component specifications, etc. Non-functional system testing is about testing everything that doesn't relate to the functionality of the system. This type of testing covers aspects such as ease of use and performance. The system may provide all the necessary functionality, but if it is not easy to use or does not perform very well, then it will not be fit for purpose. Non-functional testing is testing the attributes of a component or system that do not relate to functionality. For instance, reliability, efficiency, usability, maintainability, and portability. This is where the behavioral aspects of the system are tested. It is the testing of how well the system works. Non-functional testing includes the following types. Performance testing, concerned with determining whether the system achieves the required response times and throughput rates under certain workload and configuration constraints. Load testing, concerned with measuring the behavior of a component or system with increasing load, for instance, numbers of users, numbers of transactions. Stress testing is concerned with determining what happens to a system or component when it is used beyond the limit of the requirements. Will it fail? Will it fail gracefully? Usability testing, concerned with whether the system can be understood, learned, and used, and even if it is attractive to the user when used under specific conditions. It's more than just being user-friendly. Reliability testing is related to determining whether the system can perform its required functions for a specific period of time or for a specified number of operations under stated conditions. This is also known as the mean time between failure. Maintainability testing is concerned with how easy it is to effect a change to the system under test. If a defect needs to be corrected, how easy it is to locate the correct version of software that is wrong, how easy it is to understand the component code. If an enhancement is requested, how easy it is to modify the existing system. Portability testing is related to the determination of whether the system can be transferred from one hardware or software environment to another. The hardware or software environments need to be specified in system documentation. Structural testing is a type of testing that is aimed at exercising the structure of a component or system. Testing menu structures and code structures are typical instances where this type of testing is appropriate. We are testing to ensure that different routes through the test item have been exercised. The more routes we have taken, the greater the structural coverage of the test item. We may be required to give a level of structural coverage for a particular test item. It is not uncommon to hear someone say a specific percentage of code coverage. Through specification-based or black box techniques, we will undoubtedly exercise certain routes through the text item, but we may not realize the structural coverage target we are required to achieve. Once the specification-based or black box tests have been exercised, we can assess the shortfall and design specific structural tests to attain the level of structural coverage required. Structural testing is testing based on analysis of the internal structure of the component or system. Tests used after specification-based techniques in order to help measure the thoroughness of the testing through assessment of the coverage of a type of structure, such as code or menus. Coverage is the extent that a structure has been exercised by a test suite, expressed usually as a percentage of the items being covered. If coverage is not 100%, then more tests may be designed to test those items that were missed to increase coverage. When a change is made to a system, it is quite possible that it can have a knock-on effect. It could be that by making the change, other areas that were previously working now stop working. The system could end up worse than it originally was. Regression testing is performed to give the confidence that this has not happened. Retesting, also known as confirmation testing, is testing that runs test cases that failed the last time they were run in order to verify the success of the corrective actions. The defect, this activity is called debugging, which is not a testing activity. Remember that testing finds the defect, debugging fixes it. Regression testing is testing of a previously tested program following modification to ensure that defects have not been introduced or uncovered in unchanged areas of the software as a result of the changes made. It is performed when the software or its environment is changed. Regression testing is the repeated testing of an already tested program after modification to discover any defects introduced or uncovered as a result of the changes. Tests should be repeatable if they are to be used for confirmation testing and to assist regression testing. Remember, a good test is measurable, observable, and repeatable. Regression test suites are run many times and generally evolve slowly, so regression testing is a strong candidate for automation. Maintenance testing is concerned with testing changes made to an existing system. As we all know, change is inevitable. System requirements may change during development, but they are also likely to change once the system has gone live. The longer a system is live, the more likely change will be needed. There are several reasons why change may be necessary. Most commonly, it is because the business requirements have changed, but it could also be due to changes in technology. For instance, to help improve performance, we might introduce a new technique to help with this non-functional requirement. There can also be outside influences that affect change, for instance, changes in government legislation. Rather important to conduct impact analysis to check how the existing system may be affected by the changes, how much development effort is required for this change, what are the possible consequences of the change, which aspects should remain unchanged. Another important aspect to consider is that maintenance testing can be problematic. Specifications are out of date or missing. Testers with the main knowledge are not available. There is a lack of knowledge about the system is not fully understood, changes can be made incorrectly, and the impact of change has not been assessed properly. Testing can take longer than anticipated, and development tasks as well. Well, this wraps up for this module, so some key points to take away. The V model, the sequential development model, defines 7 stages for testing mapped directly to the stages for development. There's a clear distinction between the verification and the validation process. The iterative incremental development models and their approach to testing is quite different from the one proposed in the VID model, but there are a couple of common issues. Test levels, unit testing, integration testing, system testing, and acceptance testing are the several levels considered most common. And regarding the test types, we can see that we have functional, non-functional, structural, and testing through life of the software product. Finally, maintenance testing is due with a correct impact analysis for the changes that make the system evolve. Thank you for your attention.